Good afternoon, folks. My name is Josh Joyner. I'm the product manager of the ArcGIS GeoEvent Server, joined today by my colleague RJ Sunderman, who's product engineer on the GeoEvent Server team. Our session this afternoon is designed to provide an introduction to the GeoEvent Server and kind of its role within the real-time and big data GIS capabilities of the ArcGIS platform. So to begin with today, we're going to start by defining real-time GIS. We'll take a look at some of the different methods of working with real-time data. We'll walk through a demo showing some of this in action. We're going to discuss some of the different visualization methods available. And then at the time, we'll have some info wrap-up and some questions at the end. So to start with, we want to kind of ask the question, what is real-time GIS? I know for those of you that were here earlier in the week, when Jack was discussing some of the real-time capabilities in the plenary, and then Sud will cover them today. We just wanted to kind of take a little deeper dive into some of the real-time capabilities. So when we talk about real-time GIS, what we're really talking about is observational data. And so for a lot of people, when they think about real-time, they start to think about moving assets. So they're looking at something that's moving, and this could be maybe you're tracking a vehicle, you're tracking an animal or a person, a storm, something that's physically moving on the map, and you want to be able to kind of visualize that in real time. You want to be able to create things that occur around it. But increasingly, we're finding actually more and more use cases within the second category here, stationary. These are situations where the assets themselves aren't moving, but you have continuous data that's flowing through. So this might be something like a stream sensor or a buoy. That actual feature itself isn't moving, but it's continuously transmitting data. The final kind of real-time data that you might be working with is discrete data. This can sometimes be a challenge for some organizations to work with, but this is really data that just happens. This could be an accident. This could be lightning strikes. This could be some sort of alert or alarm that occurs. Maybe a gate got opened or a sensor got hit some sort of threshold. These are things that you don't necessarily expect to be continuously happening. You don't expect to continuously be receiving these data feeds, but you want to be notified of them when they do occur. So when we take a look at these different types of real-time data, and we look at how that fits within the ArcGIS Enterprise system, there are really 6 key capabilities that we can provide, and particularly that the GeoEvent Server can provide within the ArcGIS Enterprise system. These are, the first is to be able to ingest real-time, high-velocity data into the ArcGIS platform. This is bringing in data from lots of different sources. Part of the flexibility we have with the product is that we can do out-of-the-box connectors to over a few dozen different types of vendor feeds. If you're bringing in different kinds of, you're connecting over JSON, you're using JSON or an XML format, you're connecting over REST, you're connecting to different types of sensors. We'll take a deeper dive at some of those types in a few minutes. But the key thing is that you can bring in data from all those different sources. The other great thing about this particular component is that we can do continuous analytics on the data as it's being received. So this is slightly different from maybe more traditional types of GIS analysis where you might be working with a day or a week or a month's worth of data and then you're going back and looking for certain patterns. With real-time GIS, you want to configure your models in such a way that you're identifying patterns as the data is coming through. And the key point is you don't want to impact that flow of data. So it's always got to be kind of running on the data as you're receiving it. Now for some types of uses, you're going to want to store that data. So we need a way to be able to store this data in a way that can scale up with the potential volumes of data that you could be bringing in for real time. For us, that's done through the Spatial Temporal Big Data Store. That's the component down there in the bottom in orange, which can be utilized both by the GeoEvent Server and the GeoAnalytics Server, for those of you that might attend some sessions on that this week. We also need to be able to provide a way to visualize high volume data and high velocity data. When you start to talk about some of the quantities of data that can come in, at a certain point you get to the point where there's only so many features you can actually differentiate within a map. So there needs to be different ways of managing those imagery. And that could be either as aggregated, kind of bin counts of the features, or at certain scales you can do discrete features. We need to do notification. So when we do identify some sort of pattern in the real-time data, we need to find a way to alert users of this. And this can be done through things like an SMS message, text messages, email, or other kinds of alerts going out to a feature service, you can do that as well. And finally, the last one is really a big focus, particularly in the IoT space, being able to adjust the behavior of the environment. So when we identify that pattern, we just don't want to send an alert. We don't, if it's 2 in the morning and something happens, we don't want to just send an email out to say, oh, your office is on fire. You might want to go look at that. We want to activate some systems to try and address these things automatically. So we'll take a deeper look at each one of those 6 kind of key tasks here in a little more detail. So that first one was being able to bring in real-time data. So we have some examples of this here on the screen. So maybe you're tracking things like police cars or officers on the ground, or maybe it's an ambulance, or possibly you're bringing in different types of network sensors. So again, these are situations where the assets aren't moving, but you need to bring it in. You're bringing in sensors from some of these different types of environmental sensors. So maybe you're tracking wind speed, wind direction, temperature sensors. The key thing about this is it's not just that we're able to connect to all these different data sources, but we can bring them in a way that they can all kind of see each other. I mean, as most of you and all of you, I would assume, that have worked in GIS know some of that key value is being able to have, multiple data sources and look at them in a single operating picture. We want to do that same thing as well. So if you have data feeds from 3 different providers, we want to bring them in such a way that they can all work together and use them all within the same platform. In terms of real-time analytics, this is a key function, a key variable. This is that you need to be able to act on the data as it's coming through. So in this example here, you can kind of see we have an area that we've defined for to limit fishing. And so if we're tracking vessels, we want to be able to compare the geometry of those vessels as they're moving, comparing that to some maybe static geometry of a designated no fishing area. So when a vehicle, we can compare the geometry of that, is it inside of this boundary? And we're comparing that against both the vessel position and the information about the geometry stored. We can write that information out to a feature service, so we can write the vehicle position as well as do notification. And so that could go out to any of the applications. This could be a web map, this could be writing it out to a feature service. But the key thing is we're performing this while the data is coming through. In terms of big data storage, this can become a real challenge for users. So one of the things we were really happy to announce that with the 10.6 release of the GeoEvent Server, we're now able to sustain peak writes of up to 6,000 events per second. And when you look at, if you were to actually bring in 6,000 events of data per second, and you spread that over the course of a day, that's 500 million features when you do the math. That adds up really quickly. So how do you maintain 500 million new features every day? So this becomes a challenge. So if you're writing this out to a traditional, Oracle, SQL Server, type of relational geodatabase, that can only sustain about 2.14 billion records before it runs out of possible object IDs. So in less than a week, you would basically break all your traditional database systems trying to use it at the peak velocity. So we needed to find another solution that could scale at that. So we introduced the Spatial Temporal Big Data Store, which is based by Elasticsearch technology. It allows you to add additional nodes, and this can scale up over time. So you could start with a single server running the big data store. As you find that you need to scale it up for additional storage, you can do that. But it also provides failover. So in a situation like this where you have multiple nodes, so in this example we have 5 different servers that are running the big data store, with a replication factor of 1, you can have it always making 1 copy of the data in addition to what it's storing. So if one of the machines goes down, you always have the data in 2 different locations. And so it provides that failover by having it duplicated across multiple machines. Now, even with this, there are certain things that need to be put into place, such as you see on the right, there's a little symbol going out here to a trash can, because even if you're storing 500 million features a day, eventually, regardless of how many machines you put behind it, you're going to get into a situation where you're going to need to put some data retention policies in place to be able to control that. We have a session this week specifically on the big data store, so if you're looking at that, we can we'll show you at the end when that session is, so you can get some more information on that component. One of the other key things that we need to be able to do is visualization. So we talked about the fact that we could show these features either as discrete features or as aggregations. So on the left-hand side here, we have about 50,000 features being visualized on that map. If that had all been shown as just discrete points, you would just have this blob of points as you start to look up and down the coast of the East Coast. By doing the binning, you can actually very quickly see the difference between whether there's 100 in an area versus 1,000 in an area. You can adjust the color ramps on these, so it allows kind of on-the-fly visualization, on-the-fly hotspot, and exploratory analysis. Now we can also do discrete features. So if you want to set it by a feature threshold, anything below 10,000 features, I want to see the discrete points. You can set that as well. But the key thing is that we want to have both options as needed. Now we talked about alerting as well. How do we do notification? So here's an example where we're doing text messages. So instead of notifying when a fishing vessel is inside of an area that it's not authorized to be, we could be looking at when a child has left the school. And maybe it's outside of a certain time zone because we're working both on space and time for a lot of our properties here. So if my son's at school and he leaves school at 11 o'clock, I know he's still supposed to be in class. You could be notified of that sort of thing. And of course, this scales out, being to be able to alert your different stakeholders of the information. One of the new things we talked about in the IoT space is the actuation. So instead of just sending some sort of alert, we want to actually be able to affect the environment. So this could be something like sending a message back to shut off a sensor. Maybe we want to turn off a device. We see that a temperature has reached a certain threshold. How do we react to that? Well, maybe that means I need to activate something. Maybe it means I need to close a valve. I have a gas leak. I've detected a gas leak. I want to shut off the gas. I don't want to wait and just be like, oh yeah, there's a problem. We're going to let it continue. We want to react to it. Maybe it's something like opening a window. And a lot of this stuff, as we're able to actuate it, is all dependent upon where things are located. And that's one of the other values, and we're going to talk a little bit about that as we go on today. But things like temperature sensors, we mentioned that before. All of this has impacts where things are located. If it's 100 degrees on your loading dock, that's one thing. You have one set of actions. If it's 100 degrees in your server room, that's a whole entirely different set of concerns you need to react against. So hopefully we'll show you some different tools and some techniques of the way you can use some of those things in conjunction together today. So in terms of working with this real-time data, so we talked about what it is, we talked about the key capabilities we need to do, but how do we actually bring this stuff into the product? How do we actually use this within ArcGIS? So we provide a number of different types of connectors with the GeoEvent Server that allow you to connect to external data feeds. And we have these grouped into kind of three categories here. On the category to the left, we have what we call the out-of-the-box connectors. These are the kind of the most generic of connectors. These are ones that are not branded to any specific vendor feed, but they're ones that will let you connect to external websites for things like JSON, GeoJSON, XML, delimited text. If you want to be able to receive an RSS feed, you can do that. If you want to read from a file. Of course, we can also connect to other kind of ArcGIS central things such as feature services or other stream services. But really, these are kind of the generic connectors that let you adjust to lots of different sources. In that middle component there, we have our gallery. And these are add-on components that are available through the ArcGIS gallery that allow you to add specific vendor-centric connectors. So if you wanted to connect to GTFS, which allows you to do, they're doing the global transit feed system. So if you wanted to track buses, a lot of communities are connected to that. You can use that. If you wanted to bring in a social media feed like Instagram or Twitter, you could do that. Or if you're a shop that's using some other big data solutions like they have Kafka message buses, you could connect to those Kafka data sources and bring data in as well. These are typically more open source or organizations that have exposed their API, so we can kind of allow you to, these are connectors that we've built in conjunction with those groups. The final section over here is our partner gallery. So these are ones that have been built specifically by Esri partners that allow us to connect to very specific data feeds. So these are things like Exact Earth if you're tracking ship data, or Waze or Valarum if you're wanting to connect to some of those different sensor feeds. One of the things we added last year were the two top ones on the top right, which allow us to connect to the Amazon IoT and Azure IoT hubs. so that you can bring in real-time data from those IoT hubs and integrate that into the rest of your system as well. One thing I did not mention is you can also create your own. So we have some sessions this week that will kind of talk through some best practices on how you can create your own connectors. We actually have a session dedicated just to using the SDK if you want to get down into the level of actually working with the Java code itself and writing these connectors. On the output side, we have the same kind of a story. We have our out-of-the-box connectors that let you connect to kind of Esri standard formats, things like add and update feature services. You can, of course, add and update features through the Spatial Temporal Big Data Store, sending text messages, email alerting, as well as writing out to other APIs. So if you want to send JSON to an external website, you can do that. If you want to write to file, you can do that as well. And then we do have a gallery for these as well. So maybe you're an organization that's using Hadoop on site and you want to be able to write out to that, you can. You can send it back out to Kafka. Or if you're wanting to get into something like MQTT to send to a message hub, you can do that. And of course, we also have our two connectors for the Amazon and Azure IoT hubs as well. So in between the input and the output, we have this concept of kind of streaming analytics, some sort of processor. This is what really adds the value to GeoEvent Server, probably more so than anything else. It's not just bringing data in and putting it somewhere else. It's what you do with the data while you have it, while it's in transit. So in this example here, we have two different input sources. We're sending that through a spatial filter, looking for geometry that's inside specific zones. We're creating some buffers off of that. So we're having one output that's created, taking that data, and maybe it was point data, and I want to have a 100-meter buffer around it. Now we're having a polygon that gets created, writing out to one particular output. We have another one that's going through a geotagger processor. This is a processor that lets you add the name of different geofences. So maybe you have different service districts you might have vehicles working in. And when a pattern occurs, you want to be able to identify what district was that in. You could add that information along with the event and send it out to a second output. Or maybe you want to add something like the motion calculator, which lets you take, I know where you are now, and I get the second point a few minutes later. You can calculate the speed it took to get from point A to point B, what direction you took. Different types of more statistical calculation you can do. Here's an example. Here's the list that kind of shows all of the different types of processors that we currently support. So just like before, we have our out-of-the-box connectors as well as our gallery connectors. A couple ones I wanted to highlight on here on the left were things we mentioned before about creating a buffer and the geotagger. But there's also things like the field calculator. This works the same as a field calculator would be in our desktop platforms, where you can actually modify specific attributes while it's in transit. So maybe you have speed data coming in from a vehicle, and you want to change it from miles per hour into kilometers. You can apply the calculations, the formulas within the field calculator, and as data's coming through, it automatically does the mathematics for you to output the right value, I should say. You can also modify things like geometry in that as well. So it's not just attributes, but allows you to kind of chain together as many expressions as you want and modify the data while it's in transit. We have quite a few geometry processors. These are ones that are looking to see some sort of interaction, some sort of spatial interaction between a specific asset and some sort of stored geometry. And we also have, again, time factors in this as well. So one of the things we've probably, if you guys have seen any of our sessions in the past, we've done some demos where we see a vehicle has gone outside of an area, but it's not just that it goes outside of the area. We don't know how long it went outside. Even if you're just looking at attributes, so speeding. So you see a lot of vehicles have these things on the back that said, maximum vehicle speed is 65 miles an hour. How aggressive do you want to monitor that? Is it someone went 65 miles an hour for, 5 seconds while they were passing a vehicle, or they went, 80 miles an hour for 2 hours straight? That's a different story. And there needs to be, being able to track how long something was ongoing for. So these are types of things you can do. In this case, that would be done through our incident detector that allows you to set those time values on it as well. We have a number of different processors available on our gallery as well. These are ones that were typically built for specific projects. So maybe we built something for a specific customer, and then after that project was over, we kind of opened it up. A lot of these are, actually almost all of these are available on GitHub, especially the ones on the right. Those are all open source projects. So you're certainly welcome to take a look at those and Feel free to expand on them or use them as kind of basis for some of your projects as well. So what I'm going to do now is I'm going to switch things over. Had enough slides to start out. We're going to take a demo here and let RJ kind of talk a little bit about some vehicle location and alert monitoring.
Thanks, Josh. So as Josh was saying, GeoEvent Server is developed to monitor a sensor network, and that sensor network could be something that is fixed in place, say like the environmental controls here in the convention center. It could be sensors that are embedded in the soil to monitor an amount of water for precision agriculture and knowing exactly how much water you need to deliver to which row of crop. But something that tends to make a lot of sense when I'm demoing to people that are new to GeoEvent Server is automated vehicle location, or AVL. Because as event records are being received, you see the vehicles driving around on the map. So that's the demonstration I've prepared here for us today. On the screen, what I'm showing is the GeoEvent Manager. This is much like you might be familiar with ArcGIS Server Manager, only it's a different web application that you use to monitor, configure, and adjust your inputs, outputs, GeoEvent services. What you see here on the screen is I have a couple of inputs. I have an area of interest, or AOI receiver, and you'll see that in the demo that I'm able to post a polygon of interest and it will appear on the map. I also have an AVL receiver for my automated vehicle location, and off to the left you'll see that that is being fed from the GeoEvent simulator. The GeoEvent simulator is something that is bundled with the GeoEvent server and is probably your first application that you'll be using to feed simple comma-delimited data into your GeoEvent server just to get started with filtering and processing and seeing what the capabilities are. You'll see that I have 4 different outputs. So while every GeoEvent service needs at least 1 input and 1 output, you can mix and match inputs and outputs as you design your services. In this case, I have an AOI broadcast that's responsible for sending the polygon of interest out to my web map. It's also being used to synchronize geofences. Geofences aren't something we talked about a lot in depth. We have a session on real-time analytics, which we'll go into a little bit more later this afternoon. But GeoEvent has the ability to detect spatial coincidence between 2 feeds by using geofences to then compare the geometry from one set of events to see, does it intersect, is it within, is it disjoint, and then you can alert based on conditions that you've detected. The AVL stream is using a stream service to actively broadcast my vehicle locations out to my web map. So persistence is not something that is inherent or required with GeoEvent Server. You choose what you want the data to do based on the output that you're using. The last 2 are actually using feature update outputs. For those, I am persisting the data. I am creating feature records in a geodatabase's feature class that are exposed out through a feature service. I have a couple of GeoEvent services. The AOI receiver is fairly simple. You see it has an input. It has a schema map that's using a field mapper to prepare the data for exactly the structure and schema that that stream service is expecting, and then it just passes out the output. This is probably the simplest GeoEvent service that you can configure. It has 1 processor, which is optional, an input and an output. The bulk of the work is being done by my AVL receiver. And we'll take a look at this in a little bit more detail in a few moments after the demonstration. But what I want to show you is that you have configurable inputs, outputs, different filters, different processors. All of this is what you design as part of your GeoEvent service. So let's take a look at what that looks like on a web map. As I begin simulating data, you'll see that the AVL service is streaming using a stream service, and I've added a stream layer to my out-of-the-box portal web map and is now displaying the location of the vehicles as they move around. I've also configured the stream layer to provide me a breadcrumb trail that shows me kind of a historical position of these vehicles, so I have somewhat of an idea of where they've been and where they're going. Now, as I continue simulating, one of the 2 vehicles you see here on the top right, we start to see alerts show up. That is an alert that indicates that that vehicle's currently reported speed is greater than the speed that he's allowed to travel. So we can click on the web map and you have the pop-ups that will show that his current speed is 58 miles an hour, and if I were to zoom in, he's probably in an area that is residential or at least not freeway, and he shouldn't be going quite that fast. The pop-ups are stacked on top of one another, so here's the feature record, and it is an alert code 7. I am using these alert codes to do the unique symbology to differentiate speeding versus another type of alert that I'll show you in just a moment. And then, of course, the AVL stream, I have actually clicked close enough to 2 points, so you're seeing that at one point he was traveling 58, and maybe this is the point that he was traveling 60 miles an hour. As I continue simulating the data, you'll see that there are a couple of alerts that show up. The guy there on the top is going to enter a university area, and he shouldn't be speeding quite that fast. But let's say for a second that I have a feed, a connection to a local police department or some other source of information. And that source of information is telling me there is a developing area of interest. There's a police action, maybe there's a downed power line, it's a road closure, there's an accident, any of 1,000 different reasons why I might want to know that the vehicles that I'm tracking are entering an area of interest. So to demonstrate that, I'm going to use a plugin that I have for Chrome, and you'll see if I expand out this window, this is another way of sending data to GeoEvent. In this case, I have a JSON structure that defines a polygon. And rather than using delimited data to send it over a TCP socket, I'm actually posting the data out to a receiver endpoint hosted by GeoEvent. GeoEvent can poll a REST endpoint to receive data. GeoEvent can host the REST endpoint so that you can push data over to GeoEvent. If I do a post here, you'll see I get a response code of 200, and I have an area of interest that appears here on my web map. Now, as I continue simulating, you'll see that as one of those vehicles enters that area of interest, a red exclamation mark, as soon as that feature layer refreshes, shows up on the map, and I can begin to track the duration or just the fact that he is inside that dangerous area. That has the alert code of 1. So in this demonstration, I'm combining stream layers for live data without persistence with feature layers that are actually persisting and storing the data, and I'm providing situational awareness through dynamic geofences as the data comes through. What I'd like to do now is switch back to slides and take a look at that GeoEvent service that I brought up on the monitor a moment ago. So you'll see here that I have a GeoEvent service, and this is what I showed in the GeoEvent Manager just a few moments ago with the different filters and processors. I don't want to go into too much detail as to what these different processors are. That's more subject for the real-time analytics session coming in at 5:30. But what I did want to do is at least highlight the different portions of this GeoEvent service so that you kind of understand what is the magic that's going on behind the demo. That first line up there looks a lot like the area of interest receiver. All it's doing is taking data from the simulator, passing it through a field mapper to prepare the schema, and pushing it out to a stream service for visualization on the web map. The next block of filtering and processing going on has a filter that can't quite see there on the screen. Josh, can you tell me what that filter?
In dangerous area.
Oh, it's in dangerous area.
Sorry.
So the in dangerous area filter is using the geofence that I had synchronized to determine that the vehicle is within another polygon. And that polygon was something, of course, that I was actively synchronizing based on the stream service and the HTTP post of the information I sent over to GeoEvent. After it comes through that filter, it does a little bit of geotagging to get some information on that dangerous area, and it also does a field mapping to pass the data out to the feature service output, preparing the schema for what the feature service expects. The last portion of the service then, rather than the in dangerous area, is using a filter of is speeding. And that filter is configured to simply look at 2 attributes on each event record: the event record's current speed and the event record's not to exceed speed. Maybe you're using some sort of geofencing based on zones. You're dealing with a small enough metropolitan area that you have freeway zones and you have commercial zones and you have residential zones. And at least to that level of granularity, you can do tests to determine, is a vehicle speeding through a residential area or is it on the freeway? Or maybe like Josh was saying, all of my vehicles are trucks, they do primarily freeway travel. I don't care that they may go 35 miles an hour or 45 miles an hour as long as they never exceed 65 miles an hour. So with that, I'd like to hand presentation back over to Josh, and we're going to talk a little bit about the visualization of real-time data.
Cool. Thank you, RJ. So there's several different ways of visualization that RJ highlighted in the demo today. The first one that he was using was stream layers. Stream layers are a really effective way, particularly if you want to show moving assets, because these draw very smoothly within your web maps. These work in a subscription model, so we're actually pushing the data directly to the client. So if you have a mobile application that can subscribe to a stream layer, you can see it directly in the client. You can see it on your desktop in a web app. But the key thing about it is that, this does not require storage. So it's a great thing to use, particularly with mobile applications, where it's not having to deal with any kind of on-device storage. It's very fast. The downside of it is, there's no storage. There's no replay. It's like you load it in the browser window, you hit F5, you go, oh, let me see what happened a minute ago. Well, I can't, I just erased it. You're only getting new data coming in. So it's great if all you want to know is the current position of something. But all that information is just stored in that local session. If you want to be able to kind of go back and look at what happened earlier in the day, you're going to have to use a different model, in which case you're going to have to be able to do kind of a polling model in this case. And this is probably what most of you are more familiar with, working particularly with things like ArcGIS Server, in that you're having to do some sort of polling solution to be able to get the data. We're going to write the data out to some sort of either enterprise geodatabase, Oracle SQL Server, the PostgreSQL-based ArcGIS data store solution. We're writing these out at set intervals, and then when you want to go back and look at the most current data, you have to go back and poll this. So one of the things that RJ showed in his demo a moment ago was even after that vehicle had entered the hazardous area, that little red exclamation alert didn't show up right away, because that's a little bit of a delay. And so particularly with some of our the JavaScript applications, there's about up to 6 second refresh rate for some of the feature services. Stream services don't have that. Stream services push instantly to the client, so there is no delay. So, trade-offs in what's going to work the best for you. But the nice thing is about it, if you want to go back and look kind of at a historical level, you can go back. You can, if time is enabled, you can actually replay it within our web maps. You can actually use a time slider and replay what happened at, I want to know earlier in the day, not necessarily where the vehicles are now because it's the end of the day and all my vehicles are sitting in the warehouse. I want to go back and see what happened earlier this afternoon. You can replay that information. So I want to just kind of, before we take any questions, I want to just kind of give a little bit more of a summary about, there's a lot of stuff we covered here, and this is typically one of the sessions that has a lot of questions, so hopefully you guys have some good questions. So we left lots of time for you guys, but wanted to kind of give a summary of these capabilities again, and so we can kind of frame that for any questions moving forward. When we're talking about ArcGIS Enterprise in general, I mean, of course, we've stressed a lot in the plenary sessions the last few days. I mean, this really is a fully featured mapping and analytics platform. These are capabilities that, particularly through the GeoEvent Server, it just adds to those capabilities, those existing capabilities of ArcGIS Enterprise. It allows you to bring in all that real-time data, allows you to do different types of analysis than were ever available before. We hope that we can simplify that process of bringing in the data. That's one of the chief challenges for a lot of users probably just getting started with some of this is, can I get my data in? And we get calls, on a daily basis. I have my data in this device. It's a Motorola XYZ something. Do you guys support that? Can we get the data in? In that case, okay, it's a Motorola device. You need to work with one of our partners. In that case, then CompassCom makes the connector for Motorola. Okay, we'll get you in touch with them. But it may be something like, is it this device you've never heard of, and this is what it looks like? How do I work with this? And a lot of times that means they're going to have to work with, possibly a professional services group to be able to kind of make sure that there's a way we can bring it in. Thankfully, most of them are just kind of out of the box. We can just, oh, that's a standard format. We can just bring that in right away. But we do, we do provide the capability through, again, our SDK. We can let users create some of those custom connectors when needed. We want to be able to do that continuous analytics. So we don't really want to delay the data. We don't want to wait until the end of the day to go back and look at what happened. We want to be able to be alerted at those conditions throughout the day. So, in RJ's example, and we talked about someone speeding. Yeah, speeding's a bad thing. It's legitimately a bad thing. However, it's not something that you're going to need to stop all production to fix instantly. That's one of those things you can sometimes go back. But what if RJ was, in his demo, those vehicles were transporting hazardous material? That's a different story. And now we're like, okay, we need to know instantly something is happening. So we want to have some sort of analysis, some sort of alerting that can kind of alert both possibly the driver, possibly those back in the, someone working an executive or decision maker, back looking at a dashboard. And again, it's not just moving assets, but any kind of real-time data coming through. We want to have some way of doing the data storage. We talked about that in depth about, how do you deal with that quantity of data over time? How do you visualize that quantity of data over time? That's a huge challenge and something that we definitely need to take a look at. How do we do notification? And how are we going to do some sort of actuation, some sort of alerting, not just alerting, but how do you actually change things back in the environment? So I know a lot of, probably most of the sessions you guys go to this week will have some sort of trailing slide that says, oh, please check out our other sessions. But I want to take a little bit more time on here because I want to kind of explain some of these different sessions we have throughout the week. So for those of you that are interested in taking a little deeper dive into GeoEvent Server and some of our real-time capabilities within the ArcGIS platform, I wanted to kind of draw attention to a couple of these. So RJ mentioned we're going to have a session later this afternoon, one room over, on applying real-time analytics. This is going to take a much deeper dive into the different types of processors, filters that can be used within GeoEvent Server, how you can accomplish certain types of triggers and certain types of patterns you can look for. We have a session tomorrow morning and then repeating again on Friday, specifically about the best practices for real-time and big data GIS. This is a more of kind of a medium to advanced session. So I think a lot of the audience will, for that session, will have already been using GeoEvent. But if this is your first time seeing it, it's worth coming and at least hearing some stuff. So we can kind of avoid some gotchas before you get to that point, kind of show you some recommendations for hardware and how to and how not to configure some services. We have, if you're interested more on the IoT space, we have a session tomorrow at 1 o'clock back in this room specifically about how we can utilize some of our real-time on-premise capabilities with the Internet of Things. We have a session dedicated just to the Spatial Temporal Big Data Store. That'll be also tomorrow. We have another session, unfortunately, I think it's supposed to be Thursday, not Tuesday, on the JavaScript API using some of the web app development on that. We have a really exciting session on Road Ahead. So kind of for those of you that have seen some GeoEvent stuff over the years, you want to kind of see where we're going. That's a very exciting session Thursday afternoon. And then we have another session Friday morning on using the SDK. So a little quick housekeeping before we open it up for questions. We do ask, if possible, for those of you that are using the app for Esri, the events app, please go in and please submit stuff to the survey. It's a great way for us to kind of know what material you found helpful. If there's stuff we didn't cover you'd like to see in the intro sessions, please let us know. All of these slides and most of the session information we put out on the proceedings site, typically in a few weeks. So this is a great URL to kind of write down both for our session and then for any other sessions that are coming through. And with that, I will kind of open it up to you guys for questions. And anything? Did you have one in the back? So the question was, if you created a web service off of a MySQL database, could you use that as an input for GeoEvent Server as a REST interface? Typically, if you're going to be bringing in data from something like like a SQL Server or Oracle, any kind of database, what we'd recommend is setting it out through a feature service. If it can be done, if it can be published as a feature service, that's the easiest way to read it. But if it's coming from a different data source that you can expose as some sort of RESTful API that we can poll against, then we can certainly poll against it as well. Even if it's not a Esri native format data service, we can do that.
So even if your web service were sending out JSON or XML, that's something we can bring in right out of the box. It doesn't have to be a feature service, but it does have to be some sort of generic sort of structure that a RESTful client or server would be able to ingest. Yes, GeoEvent could host an endpoint to which your web service would periodically post data, or we could query your web service in order to pull the JSON or XML that your service was providing.
And that's a very common workflow for a lot of our kind of third-party vendor feeds. There's typically some sort of parameters you'd need to put in place, either as a GET request or a POST request. We can set those up as different fields within our input connectors, so we can pass those directly to those inputs and bring that data in. You have some other? Okay. Yes. So what the question was, what languages are these connectors in? I'm assuming the language you're asking about in this case would be Java. Are you asking about like different languages? Like, what language is it written in, or is there? So all of this is Java based at this point. Everything is Java based in this. Yep. Some of our other efforts are using, some of it can be using Scala, but it's still basically a variant of Java, but all of this is Java based. And we do have a full SDK, so it's actually included with GeoEvent Server. So when you install the product, it includes the SDK and some of the dependencies that are included. There's some sample code, there's a sample input, output, and a few different sample processors available in there that kind of guide you through how to set these up, and some example ones. Yes, in the back?
What would a workflow integrating GeoEvent Server with a runtime application? Say with the paper series. The driver has a runtime application on their device. Would you have to upload to the server and then listen to the events coming back if they were in a data area? Does that make sense?
I'll take that, Josh. So what I hear you asking is if you want to integrate with another Esri application, say like the ArcGIS collector or something else that you had developed specifically in runtime, the interface or the integration point between GeoEvent and that application would probably be the feature service. You would want to be storing feature records in a geo database that you could expose through a feature service that then GeoEvent would poll to receive that information. Of course, you could have your runtime HTTP post directly over to a GeoEvent endpoint, but most people are probably going to use the geodatabase as an integration point.
One other model we see with that similar as well is there are times where you want to actually create the output of GeoEvent would write a post request back to some sort of API. So if you had, as a part of your application, something to close the loop. I report something through the application, and when I'm done with it, I want to send something back to the application, then we would also be able to send a post going back out, going the other direction as well. So you could actually see it in the app. Yes, I acknowledge this. So. Yes.
How do you sort of set it so that it sort of, does it automatically scale up like ArcGIS Server, you can set up the minimum and maximum instances for a service, or does the service sort of automatically sort of increase instances with more number of points that are coming in?
So the question was about scaling. How do we scale up GeoEvent, the inputs and outputs for increased velocity and increased? So the way GeoEvent works is we basically have there's a functional cap on the velocity that the single GeoEvent server can kind of push through the pipeline. That's about 6,000 events per second. That's the peak it can do. We go into a little more detail on that in the best practices session tomorrow that kind of break down, some of the math on that a little bit. But really, it's if you want to scale beyond that, you're going to have to add additional GeoEvent servers to that. It doesn't audit. We don't have the concept of the pooling concept that server has, where you can say I want 3 instances of this. Once you create that input, if that input is getting all 6,000 events, then you can only put 1 input. So part of that is knowing the data. But if you have an input that's only getting a few hundred events, then yes, you could create multiple. I think some of it is I hate to say, oh, we'll just try it and see what it does. That's a horrible response, but a lot of that kind of capability is, we basically give you this big of a bucket and you can put as much stuff as you can put in it. And if you need more than that, then you need more buckets. And that's basically how it comes down to. We are excited to kind of announce also as well with the 10.6 release. We added, or I should say we replaced some of the back-end messaging system that was used. So we've went from a RabbitMQ based messaging queuing system to replacing that with the Kafka-based system that allows us to scale it out more efficiently than what we had been using in the past. So we released this week a tutorial on how to do multi-machine GeoEvent Server. So if you need to do a higher velocity, we've been doing some benchmarking, and thankfully those numbers are scaling linear. So if you need, I need 15,000 events per second, okay, then you need 3 servers dedicated to this that you can scale out.
So I think we had one more question all the way in the back on the wall.
The question is about labeling in ArcGIS Online if the label moves with the feature.
Currently, no. I do not believe the stream layer implementation for the web map supports labeling of the feature records the stream layer is displaying. The stream layer is part of the JavaScript API and has more functionality than what the out-of-the-box portal web map is exposing. So I'm not quite sure if labeling is included in the stream layer's JavaScript API definition. It may be possible if you were to roll your own web map to do what you're trying to do. If you want, you can come up and I can get you in contact with one of the JavaScript developers that will be able to dig more deeply into that implementation. It was from a stream layer, and all I did is select the layers, Symbology, and using the out-of-the-box web map shows that I wanted the transportation data set, and I preferred a green car to the red car. It was just an out-of-the-box icon.
Now, one of the nice things you can do to that point as well is you can also modify if your data is coming in with a heading value. RJ could have selected a vehicle whose natural orientation is maybe going straight up instead of a sideways car, and you can adjust the orientation based on that heading value. So as the vehicle's moving, you'll actually see the orientation adjust as the features are going through. So it adds a little extra value to the visualization. It's not just seeing where stuff is, you can actually see which direction things are going in. So even if you see a snapshot stopped picture, you know the flow of traffic at those points. Questions? Sure. Great.
So the question was kind of a system architecture question. Where is the spatial temporal big data store in relation to the enterprise?
Where do you get it? I think too. How do you get that? Does it come with GeoEvent or does it come with everything?
So it's part of ArcGIS data store. You would install Portal as a component, you would install Server as a component, you might install the ArcGIS data store as selecting the relational database, it's a Postgres database, and stand that all up on one machine, and this is your ArcGIS Enterprise. Then on a second machine, you would install ArcGIS Data Store. No additional licensing, by the way. You've licensed as many data stores as you want with your enterprise. You would then install the spatial temporal, or you would select the spatial temporal as a component or a capability of ArcGIS Data Store. And you could install 3 nodes, 5 nodes, as many machines as you need in order to scale out the big data. So it comes as part of ArcGIS Data Store, not GeoEvent. GeoEvent is a licensing role that extends or adds capability to the ArcGIS Enterprise specifically for real time. Yes, you can expose the data in the spatial temporal big data store through a feature service the same way as you use a traditional relational database. Back here in the Plaid, I saw a question.
Yeah, my question about the symbol is defined at the instance level or the level?
It's defined at the feature layer or stream layer level. It's part of the web map. We do not communicate symbology or push symbology definitions through GeoEvent.
So one key thing about that question is, where do you define the symbology? Is it at the feature layer? Is it at the service layer? It's important to note with stream services, one limitation of those is that it's one type of symbology for all the stream feed coming through. If you were doing it, if we were writing out to say a feature service, then you could actually get in and put unique object renderers, or you could put, if I had one data feed of all my vehicles and I wanted to put EMS as one vehicle, a fire truck as another, a police vehicle as another one, I could do that. Or if I have, IoT sensors and this one is temperature, this one's humidity, you could put different ones. A stream service only allows one kind of symbology for that. It's a part of the, and that's, right now that's a part of the, unfortunate limitation with the JavaScript API of what it can handle for rendering.
So it's probably something I didn't make clear in the demo. We saw the breadcrumb dots. That's a specific capability of the stream layer. I simply checked a box that said I wanted to see historical points, and the historical points could be simulated or could be symbolized however I wanted to show them. So I chose the primary point, the latest point, to be an actual car icon, and the historical points to be dots. But for the alerts, I had to use a feature layer because I wanted to do unique codes in order to symbolize a speeding alert differently from an in dangerous area alert.
Nope, let's get this guy first and then we'll come back to you.
I think so. So the question as I heard it was, where should I be publishing the feature services that are exposing data that GeoEvent wants to ingest as a poll? Kind of depends on where the data is coming from. Sometimes I want to publish my feature services locally on whatever machine is running ArcGIS Server as a component and GeoEvent as a component, because these are only services that are being consumed or used or updated as real time, and I've dedicated a certain set of machine resources to that real time operation. In that case, I might want to locate those feature services on that box. If I wanted to expose these feature services up through different web maps to clients that might be querying, that's a different use case. Those feature services probably ought to be on my hosted server so that they can be exposed through Portal and all of the web GIS. The only technical restriction is the stream service. The stream service, while discoverable through ArcGIS REST services directory is actually being run from within the GeoEvent Java virtual machine. So clients can discover the stream service, but if they want to connect to the stream service's WebSocket, they will get redirected over to the GeoEvent machine. Stream services are always published to the real-time box, not your hosted server.
So the question is, do we have any sessions that go and kind of in a little more detail in the spatial temporal big data store of what you do, kind of some of the analysis you can do on the data, either as a part of that data store or afterwards. Yes, they will actually be covering that in the session. That's why I went back to this slide. The session on Wednesday on leveraging the spatial temporal big data store. I highly recommend this session. There's a lot of capabilities that we don't even get into. It's beyond just aggregation. There's a number of different types of renderers that you can use that'll kind of highlight some different statistical properties. So there's a lot of you have a lot of flexibility on how you want to set it up. One of the things I'll tell you now, kind of a sneak peek as to the way that works, you can actually create, when you're creating the big data store data source, it's basically like a database, you can create multiple map services and feature services that point to that data source, and you can render them in all different ways. So you could actually expose one map service that provides entirely different information about the same data as another map service. So you can kind of tailor some of that to what you need at that kind of executive or analyst level going out on the back end. And they will be covering that in that session on Wednesday in the Big Data Store session.
Can we update multiple features in a feature service from a single output?
So the question is, can I update multiple feature records using GeoEvent Server? Yes. The output is simply using the track ID in order to identify the object ID or row ID of the feature that it wants to update. Then it keeps a mapping of that so that it doesn't have to do a full table scan every time it goes to update to find which record it wants. The vehicles that I was updating for alerts were using the license plate that I made up for each vehicle as the track ID, and then we're identifying which record in that relational database that I wanted to update. It's just a transaction that GeoEvent is requesting on the feature service.
What could you do about, like, say, vehicle type instead of the object ID?
Could I update by vehicle type? No, I need a unique ID because I need to be able to drill down to a single feature record.
One feature record.
Right, so if you only had one tank driving around Los Angeles, yes, I could update by type.
But and part of it is the way that it's updating the features on the feature service. So we need to have some way to know which object IDs we want to update within that feature service.
There's no functionality built into GeoEvent to find a set and update the set.
Correct.
Right. And because some of that would be, I think, you'd probably have to do that kind of programmatically to go query and come back. For us, it's like we're trying to just we're expecting a continuous flow of data, so we really try to limit how many kinds of requests have to go out and then come back again before we move forward. We try to keep it as lightweight as possible, so it kind of, there's some constraints about what kinds of processing we can do with that. Yes, against the wall. So the question was, what extension did you use to publish it? So what was the poster utility that you used, RJ?
Oh, I was Googling into Chrome extensions, and it was just called Chrome Poster. I actually have two different plugins. One is a Chrome Poster, and one is Restlet. Switch over to my monitor. So here is Chrome Poster. That's the one I was using. And then another one is the RESTlet client REST API testing. You can find either of those just in the Chrome extensions.
I personally prefer the RESTlet one. So we got about, let's see, 5 seconds left. Any other questions? Great. All right. Well, we appreciate everybody coming today. We're going to be up here for a few minutes. If you guys have any other questions, feel free to come on up to the table and ask us. So, thank you.